Hi, everyone. Thanks for coming for this presentation. My name is Balaji Ethirajulu. I work as a Director Product Marketing in Business Unit Cloud and IP in Ericsson. So today I'm going to talk about service assurance and the network analytics and its role and impact for the NFV and SDN transformation. Sorry, I got a little cold. And in the next couple of slides, I'll talk about the whole telecom industry, how it is changing, and the pace of change that we are witnessing. After that, followed by that, I'll specifically talk about how that change is going to impact the telecom network itself, and also the service assurance and the analytics solutions, actually. Finally, I'll talk about a specific solution to address these new needs, new demands that's going to come from the NFV and SDN transformation as operators are doing this. Let's talk about this. So this is the pace of change that I'm talking about. As you can see, we are all on the brink of an extraordinary revolution that will basically change the telecom industry and our lives forever. So as you see here, it took about 100 years, roughly, to connect a billion people or billion devices, basically a fixed telephony, right? Then if you see the pace of change is exponentially increasing, it took just 25 years to connect 5 more billion people, basically mobile technology. Now, we also see by 2020, we forecast around 26 billion devices that will be connected by 2020. Ericsson actually forecasted at the beginning, we had this big mobility report. It's almost sort of Bible in the mobile world, mobility report that our labs produces yearly basis. So we forecasted long time back, 50 billion connected devices. We're still on that vision. We expect that to reach eventually 50 billion connected device. What we call all of this is a network society. The people to people, things to things, device to device will be communicating to each other. So that will have a tremendous impact on the networks itself, telecom networks. We'll see that. That's the pace of change, what we call network society, right? Now, the impact of the network society, what we see, you have a different use cases. Here I'm going to talk about some use cases. We all know that traditional best effort, right, and over-the-top services, they will still thrive in the telecom network. Somehow that traffic will be carried through the telecom networks. But also, importantly, as the industry transforms, what we call 5G, the IoT, Internet of Things, M2M, so there are specific requirements that will be put on telecom networks. Specific users, specific services will expect certain things out of the telecom network, not just the free-for-all. And also, many users are willing to pay something for the better experience, for the premium experience. That will also flow through the telecom network. So you need to distinguish those traffic. The M2M side, the Internet of Things, they will look for latency, the speed, high security, depending on the industry we talk about, and the coverage. In fact, if you just take the battery on an M2M, it is expected they're looking for a battery of 10, 20 years untouched should work in somewhere in the remote places. So, I mean, that's nothing to do with the telecom, but the device expects such a strange requirements, right? So let's go to the next slide. Here, what we talk about, now all these industries, different use cases, when all these things are coming together, now that means one telecom network should help deliver the services for the multiple industry. That's what this slide is all about. So operators actually, telecom operators, they're looking at it. They should actually look at this market, make sure, develop this market, also develop these use cases that can actually cater to the needs of different verticals. So some of the different, like I explained, some of the differentiated users, different applications requires different demands from the network. So what I call is operators can actually deliver the entire telecom network service as a slice. Going back to the network slice, probably many of us in this room come from IP world. We already had We already have, logical separation of transport connectivity, right? L3 VPN, L2 VPN services, and also E-line, ELAN services in transport. Basically, we deliver to different enterprises, universities. It's logically separated in the transport network, right, today. But in a 5G concept in the network society, it's a totally different ball game that we talk at a different level when we say network slice. Just take an example. Just for a shipping industry, we're working with the shipping industry and the car companies. For a shipping industry, we're giving a complete network slice from the radio base station. They'll have their own sliced radio bandwidth. They'll have the sliced transport and also dedicated complete communication mobile core, MME, EPG, IMS, and MTAS, and so on and so forth. Including, actually, you can slice the OSS BSS. That's a complete network, a logical network communication service running on an existing network. That's the network slice we're talking, the level of network slice. But today's layer 3 VPN, E-line, they're all part of that, part of the transport. Okay, let's go to the next slide. Here, what I'm talking in this slide, now we covered the trends in the telecom, the network society, what all the different industry will come into play as part of, even before 5G, and how the operators has to address this vertical industry they will use the same telecom network that we are used for the mobile telephony and the fixed telephony. Now, as you see here, this creates a lot of challenge. The NFV SDN brings certain challenges to I'm really going to specifically talk about service assurance and analytics part of the puzzle. So as the NFV and SDN transformation is certainly going to create a lot of interesting impact on the service assurance and analytics area. If you see here, in the past, I'm just assuming that audience, you guys know certain things. Please stop me if you need to ask question in a certain area what I talk. So we have, in the mobile core, we have the IMS, right? IP multimedia subsystem, then the EPG, EPC core, the HSS, the MTAS. That's mobile core that delivers the voice communication. Today, in the past, we used to have together, right? The physical infrastructure and the network function, they were together in a single infrastructure. So the service assurance or analytics or the OSS system, they take the data from the same place and very easy to correlate. You have a single domain. What happens now that physical underneath is gone? It become virtual. So all the physical infrastructure, everybody knows that. It has become virtual CP, virtual networks, virtual memory in the data center, right? Then you have the hypervisor, then exposes as a VM to different VNFs. So we're moving our physical IMS, physical EPG to a virtual EPG, virtual IMS, right? So that means the service assurance solution in the analytics has to cope up, has to actually cover both the legacy as well as the new areas, the NFV and SDN. Also, it's very important. As we talk to several operators, like many of you here, the virtualization, the NFV and SDN, the journey has started, the transformation has started, but it'll take, for a foreseeable period of time, you will have the legacy networks. It takes a long time. You know how long it took TDM to IP? Still, there are TDM networks. And we talked IP, Ethernet, 1990s early, and then, continue to change all to IP. But still, we have TDM. A similar thing will happen in the SDN and NFV transformation. That means any system that's managing has to cope with the legacy as well as the new technologies for a foreseeable period of time. So that's an interesting dilemma for the service assurance. Now, the cornerstones of NFV SDN, we know this, right? The automation, the network agility, the service agility, it's a key part. And that means the system that's using, in the past, service assurance was very reactive. We never applied analytics a lot. Now the data science is all over in the telecom place, right? That's where the analytics comes in. So if you take the service assurance and the predictive analytics capability, now that actually impacts the automation. That closes the loop on a problem and brings the automation, which is really the cornerstone of NFV SDN. So operators are looking at, okay, now I can bring my traditional service assurance. Now the new service assurance actually will impact my automation. So that's a key point in the next generation service assurance and analytics solution is key. For example, look at the middle bullet, the proactive and predictive analytics capabilities of the service assurance system. They work together, analytics and service assurance in this case. Now we can take a very specific traffic affecting KPI, and then the machine learning algorithm looks at it, okay, that specific KPI will drive the maximum CPU utilization in a data center. If we know that information in advance, not wait for the cloud resources to come and tell us, okay, you have the CPU is going to, it's already happened, a lot of load on the data center. We can actually take, based on the VNF, what we call the application-aware scaling. We can actually scale up the CPU resources well in advance in time, actually, set up that using analytics system and the management system. You can set up on a certain date to increase the CPU resources well ahead of time. Okay, what is the result? The result will be a well-optimized telecom network tailored for a specific industry and a specific users, right? That's the result. And I talked about hybrid networks already, so what it means. Okay, now we saw all this, the industry trends and also the impact, its impact on the telecom network, also its impact on the service assurance and analytics area, right? Now, here comes a solution. For example, so this is Ericsson Network Manager. This is our management system that actually has many functions. Obviously, it manages the hybrid networks. That means it has to manage the radio, the transport, the core. That's legacy today. And also, as we migrate to the NFV and SDN, I'll talk about the analytics piece of it in this Ericsson Network Manager, just analytics application. It also has an application called Virtual Network Function Manager. That's from the Mono. It's exactly prescribed in Mono. And also, it does some network slice orchestration, as we are talking about network slice. So going back to a specific analytics application in Ericsson Network Manager. So we collect data from, obviously, as part of the hybrid networks, we collect data from across the networks. And it's important for the next generation, right? We collect data from SDN controller. The last mediation, if you see there is a mediation there, you don't see because it's just a high-level architecture diagram. The mediation plugin we had for lithium, now we are actually migrating to beryllium as well. So we'll support, basically Ericsson SDN controller, basically a copy of OpenDaylight. So basically we have, so we follow the OpenDaylight releases. So next will be to support beryllium, whatever, the TSDR, time series, there is a project there, so we collect data from that as well. The BBSC, that's a node that does the service chaining, basically delivering virtual home gateway, virtual enterprise gateway services, so we take data from that. So the interesting piece there is, I'm not going to talk about that use case here. I'm going to talk about OpenStack use case. In the SDN use case, we take the data from the controller, from the application, actually correlate that, and then we can do a service quality management, SQM, on a service chain. We can tell in advance our BBSC, okay, this particular service chain will have a problem, and they can go and actually reroute. There are a lot of things we can do on that. So I'm not going to cover that use case, but there is a use case for that. Then we also take data from CSC, Cloud Services Controller, which is our cloud networking based on SDN again. Then the OpenStack, we take data from Ceilometer, from the OpenStack, and it's ready for the 5G as well whenever that happens. So this is the data sources that's all coming in. It's a large pool of data, but just collecting data doesn't, it's just the data sitting there. So I'll talk about what we do with that. So we do, basically, all the data is collected and fed through this data processing system, basic operation, what we call in the data management, extract, transform, and load operations. So once it is done, so what the system does is it does the correlation of the data. That is also, we can use it for performance report. Once the data is correlated, it's fed to the machine learning algorithm. There are different algorithms you can select. The result of that is a very predictive, basically provides some insights and conclusions. You can use that to automate some action. Again, either manually you can do, or you can fed that automated response to a policy system, and you define a policy. Based on the policy, you can trigger a workflow in an orchestrator that goes and basically, for example, it can scale up CPU resources in the data center. That's a typical example. Okay, so time. Okay, this is one of the use cases that I'm going to talk about using OpenStack. So what it is predicting the cloud load using the application insight. So this is very important. You know, a lot of cloud infrastructure manager, we can get the data, but they're not syncing with the actual application, the VNF that's running on top. That's the critical point. If you actually correlate the data end-to-end across application, right, both actually we can see physical, PNF, and the VNF. So you can actually move the assets between PNFs and VNFs as well, depending on where the traffic is, how do you want to position the traffic, right? So here, the typical example here I was talking. So we take data from the PNF and the VNF, and then also ceilometer data, and then that's actually correlated. So network manager as that, creates the predictive, insights and conclusions. I'll talk about a demo. I cannot show the demo itself because I don't have the connectivity, but I have some screenshots that I can just explain a little bit. So here, by the way, we are working with several operators on this. So whoever is doing the transformation, I'll talk about in my summary slide what operators are looking at today, especially the one that's already, not everybody in different parts of the world, they're not there with the NFV and SDN, but especially in Europe and North America, there is a tremendous, and Australia to an extent, and Japan as well, there is a tremendous, transformation they're looking at. So in this case here, we take the data from the VNF and the ceilometer. It goes into the machine learning, as I explained, and then the machine learning creates certain conclusions and predictions. And based on that, it's fed to a policy decision engine and the workflow manager that can close the loop and increase the CPU utilization, depending on what you want to do, actually. So that's just, I'm talking CPU. It could be memory, it could be network changes, many things in the cloud infrastructure. And this is, next 3 slides is the screenshot of the demo. So this is our topology view, topology navigator, where you can see actually in a real demo, I can actually move around and see. I'm showing 3 virtual network function, 3 EPGs. You can see EPG1 there, you can see the EPG2 there, and you see the EPG3. And each of them has a different line card VMs and the controller VMs. And by actually touching that line card, I can actually tell where this virtual line card is located and which pod and which rack. It'll actually pop up. But this is just a PDF screenshot, so you don't see that. So this is the navigator. The next picture I have is this is the critical part of the whole piece. Since we have the telecom knowledge, operator will have the telecom knowledge of the network that they deliver, the services that they deliver. So you can design a particular KPI, I don't know what color, it's pink, whatever color, the bubble you see, circle on the top left there, here this side. This is the traffic affecting KPI. The system actually looked at it, all the data that comes in, and it says with a certain predictability, say like 95%, for example. It says on a certain day and certain time, this specific traffic affecting KPI is going to dramatically impact the CPU resources in the data center. Of course, people say, okay, data center, I have unlimited CPU, memory, this and that. That's fine. But is it allocated to that specific virtual network function? That's key. You can have a lot, ocean of CP, but it's how it is allocated to a particular traffic function. So here we are talking about based on VNF application scaling. So once the system gives you that, okay, this is the KPI, you can all design that because as an operator, they know what type of service and what KPI is going to impact the traffic. So once you have that information, so the system will predict on a certain day. In this case, actually, it's very small. The 20th or something, this particular KPI will increase the CPU utilization a lot. So we can take that. They can decide, actually, whether to take action manually or automated. There could be hundreds of KPIs. Certain KPIs you want to take, you don't want the telecom network run like a robot itself. You don't want to do that. So there's certain action they want to take manually, certain they want to automate it. That's how the automation comes in. So we can take that, as I explained before, that KPI can trigger, based on the policy decision, we can trigger a workflow. That workflow can go to a cloud infrastructure manager or our own orchestrator, or it could be an external orchestrator. That operator may have their own orchestrator. Go and trigger that, and then the orchestrator or a workflow manager can actually spin up a new VM, CPU VM, much ahead of time then the event even will occur. So next slide will show the difference. The top scenario 1 that I'm showing there is without any trigger, is basically there is no analysis done. You have the cloud infrastructure manager that collects the data from the data center. And then, okay, there is a load. I have about 9 CPU. The greens are about 8 or 9 CPUs there. And okay, I have a lot of load on that, so let me go ahead and add a CP. So you see the traffic event is the orange one. That already occurred. The new CPs are added much later, and you can see the CPU load has not come down. You have to know the telephony very detailed, right? The things are happening there. So it takes time for the CPU load to come down because a lot of things, people will keep on trying. If there is resources are not available. It works in a funny way in telecom. So it's not just the load. It's people try thousands and millions tries, itself a load again. So you have to take action much before, right? So the next scenario 2 is where application-aware scaling. We know, based on the predictive capability, 95% or 98%, that we take action. We actually spin up a CPU virtual machine ahead of the event that occurs. So you see that the green one, before the event occurs, a new CPU ready, and it's taking the traffic, and you don't lose traffic, and the load has come down pretty quickly. So this is just one example. There will be hundreds of examples, depending on the industry, that this, what I call network society, the one network that's going to deliver. That's, we are not far away from that already. As I told you, people are, shipping industry, we are working with the car companies, so they all need different needs. Other vertical like healthcare, as well as the, the utilities. Okay, so this is one example. Now, to summarize, based on what we have seen now, the automation and the network agility, those are the cornerstones of NFV. And as you see, there is a tremendous impact on the service assurance and analytics systems that should be capable. It should be the next generation service assurance analytics solution that is needed to manage that. Also, in the past, for operators, based on, I think most of you probably work with different operators, what we have seen, the investment goes in a traditional model. You buy the network, you spend, divert your investment to create this telecom network. Then you go and buy what you call the fulfillment system, the OSS system, your network management system. That's how the investment goes. Service assurance, yeah, but not a lot. But with the introduction of SDN and NFV, what we are seeing now, there is a big paradigm shift, the way they think and the way the industry will move. So operators now, they're looking at, okay, I need to invest on service orchestrators, right? And the service assurance and analytics system that actually needed investment so that can create my automation. Because at the end of the day, they're looking for automation and agility, both service and network agility. So that's driven, they look at service assurance and analytics solution to give them that automation capabilities. And then in our case, what we talked about is we can, not only the, SDN NFV system, but most important is the end-to-end hybrid networks, the legacy. It's very important because for a foreseeable time, future, we will have, for sure, we'll have the legacy network based on our, our experience in the past in many technologies. So that means we leverage the OpenDaylight, OpenStack, and also most of you are aware of OPNFV as well, right? So they're putting together a carrier gate system. And also we take data from OVS, Open Virtual Switch, to detect the IP addresses. So it's not just legacy. So whatever the new system that is coming, open source, and we take the data from that to create this end-to-end analytics solution. The last one is I talked about the analytics solution that we have in Ericsson Network Manager. We have about 800 plus system in the OSS today. And we are working with many operators, the one that is interested migrating to NFV and SDN, they see the critical need. So to integrate our analytics solution with that existing 800 plus OSS systems. Thank you, everyone. We'll open for any questions. If we have time, Phil. Yeah.
On the infrastructure for the all the analytics where you collect, so all the collectors, you have them in a separate repository, because you talked about different types of collectors from TSDR, you talked about, from lots of different assets. So you have a separate infrastructure for that, or is it part of your ML infrastructure itself?
Yeah, thanks for that question. Yeah, the question is, do we have collectors for different network gears, basically, right? So we've been doing this. It's a multi-vendor system. So what we call technical packs, or the collectors, or the mediation, whatever the different terminologies for each vendor. It's a totally multi-vendor. I don't know, gosh, we have like 20, 25 for switches alone. And obviously, we have one for, like I talked to you on one of the slides, we have for lithium. Obviously, we'll upgrade to beryllium release to cover what they have. We have for BBSC, one of the SDN applications, and the CSC tech packs. And so definitely, we have mediation sets for each of the different network gears. But all the data will be collected and stored in the common database, which is a highly scalable platform. And obviously, it will be fed into the machine learning algorithms to make decisions. Yeah.
Other questions?
So I just wonder, does this handle the real-time analytics?
Yeah, so please correct me if I'm wrong. The question was, is it real-time analytics, right? Yes. Two things here. So you can design the performance system, and also the real-time analytics is all about how fast the data that comes in. If you're a hybrid situation in the legacy world, you know how it works, the counters and the events, right? Events are real-time, but if you're looking at some key KPI that switches aggregate, like the TSTR also is some aggregation, depending on how fast, the whole thing depends on how fast that particular data is coming from the network. If the data is real time, there is no problem for the machine algorithm to crunch the number and provide the real time that you can loop. But the predictive analytics, if you talk about that, we are talking about advanced information, right? You can predict 1 week later, there's an NFL game in the Levi Stadium, and there'll be traffic. We know all the results last 1 month. We looked at all the numbers, and you have the algorithm that can predict, and we can actually avoid the situation by having even the new VNF, an EPG VNF somewhere in the data center here spun up already. Exactly.
Okay, Chen Li from China Mobile. Have you met some performance problem when you collect data from OpenStack, ODL, and maybe OVS, just like you mentioned? Because in our network, we met some problems when we use RESTconf and RPC, and when we use these ways to collect data from OpenStack and ODL, then there is some performance problems.
Sure. Thank you for the question. Exactly. So we have seen the similar things. That's what we work with. I have some of our guys here as well. So we work with the open source community. These are the things. Exactly you specified. We have, it's a large company. There are different sets of people work with OpenDaylight, OpenNFV, OpenStack, and to actually contribute back. In fact, there are people working with the TSTR. I spoke to them yesterday. So that has to continuously develop. That's a great part, right? So, we are looking at the application operators, and us vendors, we're looking at large vendors at least, the application layer, the telecom as a service. And then you come from there, and it goes to the developer finally, hey, this is what we need to something to deliver up there. So it's a constant, upstream activities is part of that. Exactly. Very good question. I think there's one there.
So you're saying that you are collecting data from VNFs and legacy network information also. So is it only Ericsson VNFs, or do you support third-party VNFs also? And if you do, what kind of interfaces do you require from those to be able to work with this solution of yours?
Okay. Sorry, hold the mic. I got the first point, so please correct me if I'm wrong. The first part of the question was, are we multi-vendor? We collect data from other VNFs.
Yes,
Right?
and-
What's the second part?
Yeah, so if you collect data from multiple vendors, do you publish an interface, or is there some requirements you impose on those VNFs for being able to integrate with your solution?
Okay. Yeah. Good question. Thanks for that. Yes, it's truly multi-vendor. Like you saw in the previous picture, different, not only the network gears, but we also can take from other domain managers. So obviously, each network equipment, each domain managers may have a different requirements. That's where this gentleman asked about the mediation, right? The collector-specific mediation plugin. We have to do that. Not all the plugins will affect. So for certain vendor gears, you have a certain plugin. Very similar to OpenStack, right? Ciliometer, we should have a different plugin. For the controller, we should have. For the OpenDaylight, we should have a different plugin. Did I answer your question?
So getting into a common data model for all types of information that's available in the infrastructures so that you can store in your database?
Yes. So if you talk about the network management system itself, you should have the common data model, as a data model itself. So that, but the analytics is separate, sitting on the top, analytics application. Yeah. So that doesn't matter. Your common data model or a different data model. The data it takes from the data, whatever we give, the machine learning algorithm predicts. That's a different. But for the performance report, or if you're talking about fault management and the other areas, obviously common data model is very key across radio, transport, and the core. Yeah.
Any other questions? Well, thank you very much, Balaji.
Thank you.